Is proportional to the force.
Change in momentum is
Gravitational or static.
directly proportional to the what?
Isn't it an object moves in the direction
In the direction of the net force. The object accelerates.
proportional to
And inversely proportional to the mass. Basically, the change in momentum. Change in momentum is acceleration. Change in momentum is acceleration. Acceleration is what? Change in velocity. An object will accelerate in the direction of the net force. Remember, force is a vector. So the acceleration is directly proportional to the force, inversely proportional to the mass. The acceleration is directly proportional to the force, net force, the resultant of that force, inversely proportional to the mass. Therefore, what we are saying is that the object will accelerate. Change in momentum is just the change in velocity. Momentum is a product of the mass and the velocity. That is momentum. Or in other words, you can just say an object accelerates in the direction of the net force, and that acceleration is inversely proportional to the mass. If you don't want to mention momentum. But where there is change, a force, definition for a force is what? A force is a pull or push. That's what they taught you in grade 4. Yeah. A force is an influence. I told you this in grade 3. Influence that tends to do what? To change the state of motion of an object. That is what a force is. It wants, sometimes it will change, sometimes it will not. If I apply a force on this object, the state of motion, this object is not moving, right? That's the state of motion. But I apply a force, the state of motion has done what? It has changed. It has now started moving. But sometimes you apply a force and the object does not move. It means you're not applying enough force. You may push this wall, but you apply the force, right? But the wall does not move, which means your force is not enough. But it tends, the aim of a force, it wants to change the state of motion. Change is what? Acceleration. This change. So in other words, a force wants to change the state of motion. A force wants to change the state of motion. A force wants to change the state of motion. How would it make sense? For a vehicle to move, for a vehicle to change its state of motion, there has to be what? A force. If a vehicle was not moving, for it to start moving, there has to be what? A force. Yesterday we were looking at torque, a rotational force. The engine produces a rotational force, the vehicle moves. Now, sometimes the vehicle can be moving at a velocity of 100 kilometers per hour. Then for it to change, if it is moving at 100 kilometers per hour, for it to change from 100 to go to maybe 120, there has to be a force. Newton's first law, what does it say? That is correct. So, according to Newton's first law, an object should remain in its state of motion unless acted upon by an unbalanced force. When you push an object, I push that object, according to Newton's first law, this object should keep going. But the reason why I push it, the reason why it's stopping, there is another force that is acting on it. That force is the friction force. That friction force opposes friction force opposes friction force is always in the negative. You apply a force in that direction, friction force is active. You try to push this object that side, friction force goes the other way. It is always in opposition. It is a force, and this force comes about because we have an object trying to move on another object. There is object A, there is object B, right? This object is moving on this surface. There is contact between that object and that object, therefore friction force is taking place. That would make sense. It is a force, you cannot see it, but it is always against. If you apply a force, let's say 20 newtons, friction force will be in that direction. Let's say, for example, maybe it is 5 newtons as the friction force. Then the net force or the resultant of those two forces will be 20 minus that 5. The net force is what? 15 newtons. This force is the one that will cause the acceleration. You are applying 20 newtons, but because of friction that occurs between that object and that object, 5 newtons, which is opposing that side, your net force becomes 15. This net force is the one that will cause your acceleration. That will make sense. This is the one that will now obey Newton's second law. Friction force. Friction force is a contact force. Friction force is a contact force. It depends on the contact between two objects. Object A and object B, they are rubbing against each other, there is friction. When you are rubbing your hands like this, basically there is friction between the two ends. When this object rests on that object, there is friction between the two. There is contact between the two. The more the contact, the more the friction force. The more the contact, the more the friction force. Therefore, if the surface is very rough, there will be more friction. If the surface is smooth, there will be less friction. Okay? Then you'll be looking at what is known as coefficient of friction. Coefficient of friction, represented by that symbol, is a ratio between the friction force and the normal reaction force. Perpendicular means 90 degrees. So normal reaction is the weight component perpendicular to the surface. Weight is a force, we agree. Weight is a force. The weight of 2 kgs. The mass of 2 kg. This mass is being put to the ground because of gravity, right? So 2 kg is going to have a weight which is 2 kg times 9.8 gives us 19.6 newtons. This 19.6 newtons is what is pushing this object against this surface. So this object is pushing 19,6, object A pushing against object B, right? Object B will react. Newton's state law.
Object A.
But in the opposite direction. Okay. So, in the same way, now we have finished all the three laws of Newton of motion. If this object pushes 19,6 downwards, this surface is going to react with 19,6 newtons. That's why they are calling it what? A reaction, a normal reaction, and it should always be at 90 degrees to the surface. It is a reaction. If we change the weight of this, even the reaction will change. Okay? So the normal reaction divided into the friction force will give us the what? The coefficient of friction. Coefficient of friction is a ratio. Ratios do not have numbers, do not have units, sorry. It's just a number between 0 and 1. It should be less than 1. If an object is moving, this ratio, coefficient of friction, should be less than 1. The closer it is to 0, then the surface is what? Very smooth. The closer it gets to 1, then the surface is very rough, and the object, anything more than 1, the object will not move on that surface. Okay, so the issue is the surface has to be as close to 0 as possible in order for the object to move on that surface with less friction force. If the object is on a horizontal surface like this, the normal reaction is equal to the weight of the object. In this example, the weight of the object 19,6 to push down the normal reaction 19,6. But if the object is on an incline, forms an angle. In this scenario, the normal reaction is the one that is at 90 degrees to the surface, which is this. In this case, your normal reaction is going to be the weight cos theta of the incline. The weight cos theta of the incline. Then you calculate using that. Which means if our normal reaction is the weight cos theta, which means if you are solving on an incline, if you are solving for the coefficient of friction to be the friction force over the what? The weight cos theta. But in this case, the coefficient of friction is just the friction force over your normal reaction, which is, in this case, is just the what? The weight. But when it goes on an incline, the normal reaction changes to weight cos theta. And when the object is on an incline like this, it means now the object is being attracted downwards. It will have what is known as a sliding force going downwards. A sliding force only occurs when the object is on an incline. When an object is on a horizontal, there is no sliding force. Sliding force is a component of the weight pulling the object down the incline. The incline. It is the weight component parallel to the incline, and this force is always acting downwards. It is sliding downwards. It is always going in the downwards direction. It is a force going in the downwards direction. Therefore, if you wish to push this object upwards, If you wish to push the object upwards, then you have to overcome this sliding force which is acting in the other way. As well as you need to overcome the what? The friction force. For an object to move, for an object to move, your applied force. For an object to move, your applied force should be equals to all opposing forces. Then the object will move at constant if you apply a force equal to the friction force and the sliding force, the object moves at constant velocity. Constant velocity means no acceleration. Constant velocity means no acceleration. Now, according to Newton's law, second law, we said for an object to change, for an object to accelerate, the acceleration is directly proportional to the force, right? And inversely proportional to the mass. When an object moves at constant velocity, the total force or the net force is equal to 0. When an object moves at what? Constant velocity, there is no acceleration taking place. If I've got an object, the friction force is 5 newtons, then I apply 5 newtons on this side. This is your applied force. This is your friction force going in the other way. 5 minus 5 will give you 0, right? This object will move at constant velocity. If it was not moving, then it will not move. That's what constant velocity means. It will maintain the same velocity. If it was having 0 meters per second, it will maintain 0 meters per second because it's a what? There is no acceleration. If it was already moving maybe at 2 meters per second, then I apply 5, then the object will still maintain moving at 2 meters per second. There is no change. Newton's law, we say there has to be change, right? And change is what? Acceleration. But if you apply a force equals to that, then all your forces will cancel out each other and your net force is going to be 0 and it will be what? Constant velocity. In this case, if you are pushing this object up, just a second. If you want to move this object upwards, up the incline, you want this object to go in that direction. The applied force that you need should be equal to the friction sliding force plus the friction force, because the sliding force is going in this direction, right? The friction force, you want to push this one upwards, your friction force is also going in that direction. The object will move at constant velocity, but if you want acceleration to take place as well, then you have to add your accelerating force. What is our accelerating force? Newton's second law. You cross multiply force is equals to mass times what? The acceleration. Okay, this is your accelerating force. In N3, our syllabus was looking at this only. We are looking at constant velocity. Now we'll be looking at weight with acceleration, not only at constant velocity but with acceleration. Therefore, acceleration, the force that is accelerating an object, you always multiply the force, the mass, times the acceleration. Mass of an object in what units? Mass in kgs, acceleration in what? Meters per second. Your sliding force which we have already established, I did not give you that. The sliding force will be the weight. For this guy will be the weight, sine theta. Your friction force is your coefficient times your normal reaction. In this case, your normal reaction is this. You might as well say times weight cos theta. Then we add your mass times the what? The acceleration. Acceleration is the rate of change. Acceleration is the rate of change. There has to be change in velocity. Acceleration is the rate of change in velocity, which means there has to be a final velocity minus initial velocity over time. We'll be looking at this for almost all our studies. There has to be a final velocity minus the initial velocity over how much time. We can as well use this other when we are given the displacement. And we solve for our acceleration. That is just our acceleration. How do we get this acceleration? We can use this or we can use that. Or we can use this other one, ut plus half at squared. We solve for that. Now, when the force is applied on an object, I apply a force on an object. This object moves from one point to another, then work is done, right? Work is done. Work done is a product work is done only if an object is what? Displaced. Displaced means, or displacement means the object has changed position, then work has been done. If I push this wall with a force and this wall does not move, then there is no work done. If I push this table, the table moves from where it was to a new position, work has been done. Therefore, work done is the what? Force times the what? The displacement. Units for work done? Joules. You'll be using G. Work done is a product of the force and the displacement. The rate at which work is done, that is power. We looked at power yesterday. Rate at which work is done. Or work done per second. We can as well use power is equal to the force times the what? Times the velocity. Yesterday I gave you a formula for calculating for power using torque. But now this is power using a force and you have a what? A velocity. A constant velocity. Your velocity should always be in meters per second. Your force is always in newtons. What is the unit for power? You'll be using W. Now, in our questions, in our exam, we'll be finding ourselves with all of this under dynamics. It's basically movement. Dynamics is basically movement. What we'll be first with is questions like the vehicle. They'll say a vehicle goes up an incline with a ratio of this incline is 5 to 20. 5, which is our y-axis, 20, which is our what? Our x-axis. If they give us as a ratio, it means they're not going to give you the angle of that incline. Which means with this object, if you are to calculate the sliding force, which we said is sine theta, you need to figure out what that theta is. Okay? So every time, and in most cases, they'll give you as a ratio. If they give you as an angle, you just replace that angle there in degrees, you get your answer. But if they give you as a ratio, then you have to do the 5 will always be the y-axis, then x-axis for the other one. Therefore, if you are again calculating for the normal reaction, remember it will be the weight cos, again that theta will come. You still need to know how much theta is. But keep in mind, I'm using the what? The weight. I'm not using the mass. We won't use, for this one, we won't say 1,600, then we say sine theta. We say 1,600 multiplied by what? 9,8, then we say sine theta. How do we get the theta? Opposite. This guy is what? Adjacent to that. It does not mean this 5 is the height. It is just a ratio. How would it make sense? It's a good question. So, in your maths, how do you solve for incline of a straight line?
Incline apa? I see incline. Oh, belum straight line. That's a straight line.
Ini dari angle topik
That's gradient. Okay, continue.
Gradient of a straight line. That's the incline of the line. It's what? Change in y over change in x. So always. Yeah. Gradient is just a ratio. Gradient is just a ratio. So every time they give you a ratio, basically they have given you the what? The gradient or the incline of that line. Always take this guy as the first guy. Y, the other one will be x.
How do we get the angle? Tan theta, and we say opposite y over adjacent. Theta is equals to tan inverse y, changing y over changing x.
That angle you have got here, you said 14 comma something, right? That is what we'll use here, 14 comma whatever. That is what we'll use there, 14 comma whatever angle. When we come to calculate the normal reaction, where do we need the normal reaction? In calculating for the friction force. Where do we need the sliding force? In knowing how much force is opposing when the object is going upwards. Remember what I wrote? Force needed to go up the incline, it will be the friction force plus your sliding force plus your what? Acceleration. This guy is gonna need, this is friction force, is gonna need the coefficient times the normal reaction, which is this guy. This one needs the weight sine theta, which is this one, which still needs our angle there. This guy on the other side is just the mass times the what? The acceleration. The mass of the object times how much acceleration. If they say from here, from the bottom of this slope, the velocity was 0. This vehicle starts going upwards, it reaches a finite velocity of maybe 20 meters per second. Then there is a change in velocity. Finite velocity, initial velocity. Probably they give you even the what? The displacement. How much displacement took place? Then you are calculating for the acceleration. 150. The vehicle starts from rest, moves 150 meters. It reaches a final velocity of 20. What is the acceleration? V square is equals to U square plus 2 acceleration that.
We can use, wait, we can use the one of V minus
V V minus U over, do you have your time? You don't have the time. If you have the time, you can use that. But if there is no time, if there is no time, you can use this one.
V square minus U square is equal to acceleration 2s 20 minus 0 square over 2 times
150. This gives us our acceleration. Meters per second square. It is a square. Meters per second. That is the acceleration. Meters per second. If we are solving for the what? For the friction, for the accelerating force, we will take that 1,33, we multiply by the mass. How will make sense? If we are looking for this guy, the friction, the sliding force, we will take the weight of the object, the weight which is 1,600 times 9,8, sine the angle 14, whatever that you got. This will give us the sliding force. Where is the sliding force? The sliding force is acting against this. Is trying to go up, but the sliding force is acting in that direction. The acceleration is acting in that direction. The friction force, but with the friction force, you need the coefficient of friction, which I said they will give you in most cases, or you're calculating for it. They will give us this, which is just a ratio. For example, if they say the coefficient of friction of this surface, coefficient of friction is the property of the surface. Let's say they say 0,3, just as a ratio for this. We'll say 0,3 times the normal reaction, 1,600 times 9,8, cos your 14, whatever value that you got. Then you'll be adding all of this, you get that, and you get that amount. It will give us how much force in newtons. Now, lastly, let me mention these two. Energy. Ability to do it. What do you want? Energy is ability to do it. What else do you want? Now, when you say to do work, right? Is that work done we're talking about? Work done, we said, is what? The force times the what? Times the displacement. If, isn't it in this vehicle, there's a small engine in there, right? Yes. The engine is the one that is making this vehicle to move from there, accelerate, reach 20. That's the small engine in there, burning up fuel and so on. The force that the engine is producing should be a total of this much. If the engine fails to produce a force of this much, this vehicle will not move up and reach 20 meters per second. The engine should be able to produce a force that will overcome friction, it will overcome sliding force, then to also accelerate the vehicle at this much. Okay, so if the vehicle fails to do that, then all of this scenario will not happen. If the vehicle only produces this amount of force, then there will be no acceleration. The object will move at a constant velocity, but for our syllabus, now there's going to be acceleration taking place. Okay, so now the vehicle produces this amount of force, and the vehicle moves from point A, it is now at point B, right? Therefore, the force that was produced has been able to move the car from one point to the other. It has been displaced, therefore work has been done. Do we agree? When the force moves an object from one point to the other, there is displacement, work has been done. Energy is the ability to do work. But this ability, we are just, I can say it is a possessed work done. We are not doing the work done, we are just containing the work done. Okay? If I say I can ride a bicycle, but I'm not riding a bicycle now, I have the ability to ride a bicycle. Right? Yeah. I have the ability. In the same manner, this vehicle, if it is at this point, what it is possessing is energy. When it starts moving, it starts converting that energy into what? Work done. The vehicle has got energy in form of the fuel inside there. Fuel which will be burnt tends to heat energy. The heat energy is tends to mechanical energy that the vehicle moves. Okay? But the fuel has got energy which is now in form of heat energy. Heat value of that fuel. We are not looking at that. But what I want us to look at is now, as this object moves, there is now a transfer of energy from one form of energy, like I mentioned, from heat energy. It is converted into kinetic energy. What is kinetic energy? Energy.
Energy. That an object is
Energy, yeah, that is object. Due to movement or motion. So an object which is moving has kinetic energy. If an object is not moving, there's no kinetic energy, only if it is moving. If this guy was at 0, there is no kinetic energy. When it starts moving now, there is what? Kinetic energy. As this vehicle is moving from 0 up to 20, the kinetic energy is doing what? It's increasing. Kinetic energy is half the mass times the velocity squared. If this was 0, then everything will be 0. There is no energy there. When the object reaches 20, the kinetic energy also increases. The kinetic energy depends on the movement of the vehicle or the object. If there is no movement, there is no velocity, it means there is no kinetic energy. If the velocity is 0, then it means kinetic energy is what? 0. There is no movement. But if an object is accelerating, in this example of ours, from 0, it goes to 1, it goes to 2, the kinetic energy is increasing. If it is 1, we multiply 1 squared times half the mass, that will be our kinetic energy. It goes to 2, we square that 2, we multiply by the mass and half of that. As it reaches 20, the kinetic energy is even greater. The more it accelerates, the more the kinetic energy. Kinetic energy is energy due to motion. And you write something like this in your exam.
the
energy, yeah, that's an object has
Are the two statements different?
still the same but short.
If the velocity of the object is 0, then it means there is no kinetic energy. That would make sense. If the velocity is what? 0. An object can have initial velocity. It is not always that an object will be starting from rest. Sometimes an object, maybe the initial velocity can be, let me say, 4 meters per second. It is already moving. It is already moving. Therefore, it already has kinetic energy. Whether it is moving at constant velocity, let's say 4, it is not changing. It maintains 4. It reaches here, it's still 4 meters per second. The kinetic energy here, you multiply by 4 squared. The kinetic at the top will still be what? 4. Now, in this case, there is no what? There is no acceleration. How would it make sense? Because the velocity is not changing. But the object still has what? Kinetic energy because it is moving. Only if the object is not moving, that's where there is no kinetic energy. Potential energy. What is the unit for energy? energy due to vertical position. Okay. Vertical position, straight 90 degrees. When the object is at the bottom of the slope, there is no potential energy. Because if we say the mass of this object, 1600, we multiply by 9.8, we multiply by, there is no height here. It will be 0, which means there is no potential energy. Potential energy is because of what? A vertical position, because of its position above a reference point. If the object now, this vehicle, it is moving upwards, it is accelerating, the kinetic energy is increasing. Also, it is gaining what? A height above the ground. So this height here, not 5. 5 was a what? Was a ratio. The height is not 5. 5 was a ratio. Here you said you got 14, my point is, you need to figure out this height from there up to there. If you have traveled 150, you have your angle, it means you can solve for that. Does it make sense? You create a triangle, 150 is the hypotenuse, this is the opposite, you have your theta. Our height is going to be 150 sine 14,036. Vertical height, we need this height. Please do not multiply the length of the slope. The length of the slope is not your height, is not your vertical height. The length of the slope, you use it to get this, provided either they've given you your angle or you have calculated for your angle.